All right, so in this video, we're going to go through sample question 28 from the Society of Actuaries, list of ExamP sample questions. The question reads, a hospital receives 1/5 of its flu vaccine shipments from company X and the remainder of its shipments from other companies. Each shipment contains a very large number of vaccine vials. So for company X's shipments, 10% of the vials are ineffective. For every other company, 2% of the vials are ineffective. The hospital tests 30 randomly selected vials from a specific shipment and finds that one vial, exactly one, is ineffective. We need to calculate the probability that this shipment came from company X. Okay, so what is this question asking us? This is a pretty interesting question. It combines a couple of very important concepts that are crucial for ExamP. So it's asking us the probability that this particular shipment came from company X, given the number of ineffective vials there were, is equal to 1. So I'm just going to say that I is equal to 1, right? So conditional probability, right, should be second nature to you. Probability of coming from company X and having a specific vial being ineffective, one vial being ineffective from a larger sample of 30, divided by the probability that one vial from a sample of 30 is ineffective, right? Regardless of where exactly it came from. So that's what it's asking us. Let's now write what we're given. We're told that 1/5 of its vaccines are from company X. So the probability of coming from company X, well, that's going to equal 1/5, right? The probability that you come from a different company would, so not X, would then be 4/5. And what else does it say? 10% of the vials are ineffective. So the probability that a particular vial is ineffective coming from company X is 10%. So the probability of one specific vial being ineffective coming from X equals 0.1. And the probability of one specific vial from any other company is 0.02. Now, here's where the tricky part comes in, right? We didn't just pick up one random vial. We select 30 of them, and of the 30, one specifically came up ineffective. And that describes a binomial random variable, right? This video, I don't have enough time really to go into like all the specifics of it. I'm kind of assuming you're familiar with a binomial random variable, but a brief overview, it describes pass-fail scenarios. So in this case, a vial is either ineffective or it isn't, right? Where oddly enough, we're considering a pass being an ineffective vial. Okay, so what is the probability of coming from company X? So first, we're dealing with a binomial random variable, and for this portion of the problem, we're also dealing with Bayes' theorem. So using the formula for Bayes' theorem, this should be equal to the probability of the vial showing up from company X multiplied by the probability that a randomly selected, from a sample of 30 randomly selected vials, exactly one comes back ineffective, given that it's from company X. Over, well, what's the probability of having one, from a sample of 30, of having exactly one ineffective vial? Well, you're either having one ineffective vial from X or one ineffective vial not from X. So that's going to be the probability of X multiplied by the probability of having one ineffective vial not from X, or sorry, from X, right? Plus, so that covers the option of when it comes from company X, and this next part covers the option when it doesn't come from X. So probability of not being from company X times the probability of having exactly one ineffective vial, given that you're looking at a sample not from company X. Okay, so let's figure out these probabilities. We have the probability of X and not X, right? So we have these items. What we don't have is these conditional probabilities. So let's first look at the probability of having one ineffective vial, given that you come from company X. So here we have a sample of 30 independent trials, right? That would mean that's going to be, and the general formula for a binomial random variable should be n choose x multiplied by the probability of a success, so p, to the x power times q, or p minus 1, which is the probability of failure. So I'll just write q for now, of n minus x. Okay? Something you should really be familiar with. Binomial random variable is, I think, one of the, that and a Poisson random variable. Those two are the most common to show up discrete random variables for ExamP. I can't stress enough how important it is to know. So here, filling in that information, there are 30 trials. Choose one success in terms of like one being ineffective, times the probability that of having a success from company X. Well, it's 0.1 right here. 0.1 raised to the first power, multiplied by the probability of failure. We should have 29 failures. 0.9 to the 29th. And similarly, the probability of having exactly one vial be ineffective, given that you did not come from company X. That's 30 trials, one success, times the probability of a success, which is 0.02, raised to the x power 1, times the probability of not having a success, which is 0.98, raised to the 29th power. And we need to find the values for each of these. And that I'm just going to use a graphing calculator for. As incredible as I am, I cannot do this in my head. I would like to meet somebody that can, though. They would probably be super genius. All right, so let's see. 0.1 raised to the first power multiplied by 0.9 raised to the 29th. And that would get me approximately 0.1413 probability. Similarly here, plugging in the same probabilities, albeit somewhat different. Instead of 0.9, it's 0.98, and instead of 0.1, it's 0.02, and that's equal to 0.333. Just that. Okay, now that we have those values, what we're going to do is plug them in to this formula, right? And I'll write it down here. So we're going to have the probability of x, which is 1/5, multiplied by the probability of having one ineffective vial, given we come from company X, so that's this guy right here, 0.1413. And what I'm doing, and I'm going to just show you a quick calculator thing, is I'm grabbing that number and I'm just going to store it as X, so it's easier for me to put into my calculator. Not really so much of a big deal. And I'm going to store this one as Y. Store as Y. Right? That's not so much important to the, probability theory thing, but it'll just make certain things faster. At least they do for me. So this is going to be 1/5 multiplied by 0.1413 plus 4/5, right? The probability of not being in company X, multiplied by 0.333, right? which is the probability of having exactly one ineffective vial from a batch of 30, given that we're looking at a batch not from company X. Now, this is what I put into my calculator. So that's going to be 1 over 5 over 1 over 5 plus 4 over 5, and that gets me an answer of approximately 0.0956576. Now, the answer choices are to the second decimal place, so I'm going to round that to 0.10, which is answer choice A. All right, so what can we learn from this problem? Well, the first bit of it involved setting up your conditional probability, right? So you set up your conditional probability, you realize, okay, I don't actually have this information in terms of X and exactly one vial from a batch of 30 being ineffective. So I set up Bayes' theorem. And from Bayes' theorem, you realize, okay, I have X and not X, but I don't have these particular conditional probabilities, but I know how to get them, okay? So given we show up from X, right, ignoring everything else, saying, okay, we got a batch from X, and I get 30 random samples. What is the probability that exactly one is ineffective? That is a clear-cut scenario of when to use a binomial random variable, right? That kind of one of the telltale signs is independent trials. Another thing is each trial has the same likelihood of being of having a success, right? Again, if you want a separate video where I just discuss the binomial distribution, I might just make one anyway because of how important it is. Just let me know in the comments. I currently don't have one, right? So plugging it into the equation gets you those probabilities, right? Hopefully that's clear, and I'm going to say it again. Make sure you know what a binomial random variable is. Make sure you know the probability function, moment generating function, expected value, and variance of it. Very important. If this video helped you out, hit the like button, subscribe. That definitely helps me out. If you want to see more problems worked out, I have a playlist off to the side somewhere, or probably in a suggested video. Go check those out. If there are any questions, throw it down in the comments. But other than that, good luck, guys.